Sometimes you're going to get a function that has y that's not by itself. Your first step that you want to do is to make sure that you isolate y. So our example here is the absolute value of x minus 5 is less than or equal to 4 minus y. Well, right away I see that this negative is with this y and I want to make it positive, so I'm going to add y to both sides to get y to be positive. So since I added on the right, I got to add it over on the left. It's going to be plus y over here. So what it gives us is y plus the absolute value of x minus 5 is less than or equal to 4. And we don't need to change the sign of, or excuse me, the direction of our inequality because we didn't divide or multiply by a negative. The next thing we need to do is then to get y by itself, we need to subtract this entire absolute value of x minus 5. We can treat this as an entire term. And since there's a plus sign out front, we have to do the opposite, which is a minus. The absolute value of x minus 5. And we'll subtract it on both sides. And okay, so it crosses out here. And what it leaves us with is y is less than or equal to 4 minus the entire absolute value, which is x minus 5. So the whole purpose of that was just to get y by itself. So when we do our input values for x, we don't have to be calculating, trying to divide or add or subtract to try to find y. We'll just get a value for y. So now if we go over to our table here, so I have some predetermined numbers here for x, and if we put them into our inequality for x, it'll give us something for y. So 2 in for x, 2 minus 5 is negative 3. Absolute value of that is 3. 4 minus 3 is going to be 1. If we put in 4, 4 minus 5 is negative 1. Absolute value is 1. 4 minus 1 is going to be 3. And then we put in 5. 5 minus 5 is 0. Absolute value of 0 is 0. 4 minus 0 is just 4. And then for 6, we have 6 minus 5, which is 1. Absolute value of that is 1. 4 minus 1 is 3 for our y. Let's come over to our graph and let's plot these points. So 2, 1, 1, 2, 1 is there. 4, 3, 1, 2, 3, 4, 1, 2, 3, 5, 4. We got 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 6, 3 is going to be right here. Okay, so those are just the 4 dots we have so far on our graph. Then we need to look, is this going to be a dashed line or is it going to be a solid line? Well, since it's equal to as well, it's going to be solid, so we can extend our lines as solid lines, and I'll do this the best I can. And down here, okay, that will continue on forever. And the last thing we have to do is figure out what side of the graph to shade on. Let's just pick a point that we know is somewhere on our graph. So pick a point inside, pick a point outside. So I'm going to pick something that's simple. So I'm going to pick 3, 0. So that's 1, 2, 3, 0. So that's this spot right here. And if I plug that into our inequality, does it true or not? So, well, we had 3 minus 5, which is going to be negative 2, which gives us absolute value of that is 2. And we have 4 minus 2. 0 is less than or equal to 4 minus 2, which is 2. And is that true? It is true, so that means we shade inside of our V. And so actually all of this up here is going to be shaded, because if we continued this line all the way down, it would include all of this information inside the V that needs to be shaded.